Hello everyone. In this video, we are going to see the blockchain as a distributed ledger. It's presented by me, Elite Engineer, and this is a third part of our blockchain basics which we are going to see. So today, when we see as a blockchain as a distributed ledger, we have already seen in the previous video. If you have not gone to the previous video, I request you to first watch that part and then you can come to this part to understand it much more better way. So what we have seen in the DVD example that A, B and C we have considered, and they are keeping the record of all the ledger if they are borrowing the DVDs or they are requesting the DVDs and so on. Now that we have a better idea of distributed ledger, we can now associate it with the term blockchain. Using the DVD rental example, each time a DVD is borrowed or returned, a transaction is created. A number of transactions are then grouped together to create a block C. Now, this block is created when A borrows 5 DVD from B. So 5 A and B, and then A borrows DVD 6 from C, 6 A C. B borrows DVD 7 from A, 7 B A, and here the different blocks are created, and these blocks are grouped together to create one more block, and these all are chained together. That is chaining of blocks. Hence, that's why we call it a blockchain. Block and that are chained together, right? So a number of transactions are grouped together to create a block. As more transactions are performed, the blocks are linked together to cryptographically, forming what we now call it as a blockchain, right? So based on what we have already discussed, we can now summarize some of the few points. So centralized databases and institutions work when there is a trust in the system of law. In the first video, if you memorize, we already learnt about the trust factor that has caused to to evolve as a blockchain technology, right? So a decentralized database built on a blockchain removes the need for the trust in the central body. Now no need to trust anyone. Now we have a database, everyone has a copy of that. If someone removes something from that, we can check from somebody else inside in the globe, because it is distributed across the globe in different computer systems, right? So a blockchain can be used for anything of value. It's not about cryptocurrencies only. It's not about Ethereum, Bitcoin, but it can be used for anything, like for storing our documents and so on. Now let's see how blockchain work, right? So this is our blockchain. In this first block is our Genesis block. Then there comes block number 2, block number 3 and block number 4. At a very high level, a blockchain consists of a number of blocks. Each block contains a list of transactions, 1, 2, 3, and how many transactions you will record, it will contain that. The blocks are connected to each other cryptographically, right? This is connected to this block, this is connected to this block. And each block which contains the list of transactions, as well as they also contain the timestamps, right? So what happened here is the blocks are connected to each other cryptographically, the details in which we will discuss in the next section, which we are going to see ahead. And the first block, which is known as Genesis block, that must contain in every blockchain. So in the future video, when we will see that when we are trying to create a blockchain network, so we have to first create our Genesis block in that. Okay, so I'll just show how we can create that Genesis block in the future upcoming videos. Okay. So how do you chain the blocks together? That is our question. Like you have created a block. We have created a transactions, and that transactions are grouped together to create a block. Now, how do we chain them together? Okay, so let's see how to chain them. To chain the block, before we discuss how the blocks in the blockchain are chained together, we have to discuss a key concept of the blockchain named as hashing, right? So before jumping to the complex part, we have to first see about the simpler part. What we call is hashing. A hash function is a function that maps the data of arbitrary size to the data of fixed size. Like what happened here is, if we contain some data and we are getting some fixed bits of our data. Okay, so I'll just show in the upcoming next video like how we are containing that. Okay, so I should move further. By altering a single character in the original string, the resultant of the hash value is totally different from the previous one. Most importantly, observe that a single change in the original message results in completely different hash, making it difficult to know that the two original messages are similar, right? So what I'm saying here is, like in the previous case, if I go through the previous, this one. So here what happen is, in the transactions, if these, I'm listing the transaction in the blocks. Okay. After listing the transactions, here one sample code will be generated, that is a hash. Okay. I'm just giving an example for you. So here one hash is generated. Now, if you change something here, so that hash function will also change. Now that hash function will be stored here, because block 2 will contain the hash of the genesis block, then block 3 will contain the hash of block 2. And a similar way, if we change something in genesis block, the hash will change, and that hash need to be changed in the block 2, and then block 3, then block 4. So if someone try to modify something in one block, that hash function will change, and then he has to change the hash of all the continuous blocks. Otherwise, every block will become invalid of that. Okay, this is a basic aim of creating a hash function here. Now, a hash function has some of the following characteristics. It is deterministic. The same message always results in the same hash function. Like if I wrote that my name is Elite Engineer, so it will create hash function same every time I write my name is Elite Engineer. If I write that hello, my name is Elite Engineer, the hello which is being added will create a different hash function compared to my name is Elite Engineer, right? So it is one way process. When you hash a string, it is computationally hard to reverse a hash to the original message. So it's difficult to decode. So that's why it's difficult to hack. So no one can detect from hash function what data is there inside. That's why it is much more secure as we compare to the other systems. So it is a collision resistance. It is hard to find two different inputs messages that are hash to a same hash, right? Now, we are now ready to discuss how blocks in the blockchains are chained together, because we have already known that what is my hash and how it is being generated. To chain the block together, the content of each block is hashed and then sorted in the next block. So I have already explained in the previous video of our transactions, like we have different transactions that are created and we are creating a block of that. And with that, we are also having the timestamp. Now, this block will give me some hash function, and that hash function will be stored in the block 2. So this is containing the hash of what genesis block, and then transactions of this block, and then timestamp, and further including the hash of this previous block and the transaction of the current block. It will create some hash function of this block, block number 2. That hash function will be stored in block number 3, and the further transaction will be stored in block 3. And a similar way it continues. Okay, to chain the block together, the content of each block is hashed and stored to the next block, as I've already explained. That way, if the transaction in a block is altered, that is going to be invalidate the hash of the current block, which is stored in the next block, which in turn is going to invalidate the hash of the next block, and so on. If you change this, hash will change, then we need to change the hash of this block, and then continuously every block will become invalidate, right? So observe that when the hashing the content of a block, the hash of the previous block is hashed together with the transaction. I've already explained that hash function will also be included in the new hash that will be generated from the new block, right? I repeat, the hash which is being generated from the previous block will be used to create a hash of the current block, right? However, do take a note that this is a simplification of what is in a block. Later on, we will deep dive into the details of a block and see exactly how the transactions are represented in a block. Storing the hash of the previous block in the current block assures the integrity of the transactions in the previous block. Any modification of the transactions within the block causes the hash of the next block to be invalidated, and it also affects the subsequent block in the blockchain, right? If a hacker wants to modify our transactions, not only he must modify the transactions in the block, but also in the subsequent blocks in the blockchain. In addition, he needs to synchronize the change to all other computers on the network, which is in the computationally expensive task. Hence, the data stored in the blockchain is immutable, for they are hard to change once the block they are added to the blockchain. Okay, so it is difficult to change. That's why we use blockchain. So up to this point, we have a higher level of overview of what constitutes a blockchain and how the blocks are chained together. In the next videos, which we are going to see, we will understand the important topic of a blockchain known as mining. And be there in the next video, because this is an important topic of blockchain mining, and in the upcoming videos we are going to mine blocks also. Mind it. So be there in the next video. Thank you for watching this video.